You ready? Okay, we're at 5.7b. I'm on page 213. It says I got an 8 by 12 beam. 8 by 12 beam, number 1 grade, dug for a larch. 16 foot long. Supports a total uniform load of 6,000 pounds. And it's asking me, investigate the deflection if this guy right here is limited to L over 240. Okay, here we go. Okay, I go to page 114. I look for that picture. Okay, so I'm going to do that. I find case 2 fits it. Just about perfect. So I write it down. Little delta, so I've got L over 240 equals big delta is less than or equal to little delta, which equals 5W L cubed over 384 EI. Okay, there we are. Fill in the blanks. Now, I'm telling you what's going to happen. You're not going to look at units at all, and you're going to have this thing all screwed up. Make sure the units, that length is 16 feet, but in my world it's 16 times 12. So look at, I'm going to populate this. The W is a 6,000 pounds. Okay? Running out of ink here. 6,000 pounds. The L is 16 times 12 inches per foot cubed. 384 is a constant. I've got a 8 by 12, so I go to the back of the book and I pull the I for an 8 by 12. 8 by 12, I. There you are. 950.5. E is table 5.1. It is bigger than 5. It's number 1 and it's a beam. It's bigger than 5. It's a number 1 and it's a beam. Second cell. Number 1. All the way across to the next to last column, and I see 1,000,006. I've got an L here, 16 feet, 16 times 12 divided by 240. Everything's there. Do the math, see if it works. This is 16 times 12 divided by 240. Okay, what do we got? Let's see what we've got. Get rid of this, get rid of that. 16 times 12, 16 times 12, 16 times 12 divided by 240. 0.8. Five times 6,000 times 16 times 12 cubed divided by 384 divided by 1,000,006 divided by 950.5. Is that a true statement? Is 0.8 greater than 0.36? Yes, it is. We're okay. So that's all you got to worry about right there. Okay, let's do another one and see what we end up with. I don't know if that's the right equation. I'm going to save it just in case. It may or may not be. May have to erase it. Let's go to number 3.7D. 3.7D, or 5.7D, excuse me. It's on page 214. Okay, what do I have here? I've got a 8 by 14 beam. Select structural. Select structural, Doug Fir Larch. Span of 16 feet, 8 kips. Investigate. Well, 16 is my span. So this is equal to 16 times 12 divided by 240. 8,000. Okay, it is a select structural. It's bigger than 5. It's a beam, so I'm going to go to cell 2. So I'm going to move into cell 2. I'm going to put my finger on select structural. I'm going to go over, and I get 1,000,007. I'm going to look up the I for an 8 by 14. It's in the back of the book. An 8 by 14 has an I of 1538. 1538. Multiply them out, you should be done. So I take 8 grand. Uh, 12 times 16 cubed divided by 384 divided by 1,000,007 divided by 1538, 0.06. Let me make sure I got that right. I want to make sure I didn't do something. I think I did something wrong here. 5 times 8,000 times 16 times 12 cubed divided by 384 divided by 1,000,007 divided by 1538. Yes, I did. 0.28. Is that a true statement? Yes, it is. I'm done. Okay, let me look at the last one and see if it's a redundant problem. If it is, we're not going to do it. If it's not, we will do it. 5.7E. Let me see what it says. It's the same problem. It's a simply supported span with a total uniform load of 10 kips, so it's exactly the same. So that takes care of deflection. Page 114, that's all you got to worry about. Now we're into rafters and joists, and this is just reading tables. So let's go through it, make sure you understand it, and then I think we've got this part whipped. Okay, you're going to have to turn to 5.9 in your text. And the tables I'm talking about are mirror images of each other on 2 pages, 224 and 225. Okay, 224 is joists, 225 is rafters. Hopefully you understand what they are. If I was building a house, there's the basement. Okay, I put a plate on top of the wall, put a beam in the basement, plate on top of it, and then I put floor joists on it. Floor joists are members that create the base for the sheathing to hold you up when you're walking in a house. So if you go down in the basement and you look over the top of your head, you're looking at floor joists. Okay? Then the floor joists have a sheathing on top of them, and then they've got walls sitting on top of them, and I'll just draw this in. And then you've got ceiling joists and rafters. The rafters form the peak of the house. Okay, the rafters come together in a ridge board at the top. That's the ridge. Okay, so the span. If you look at the picture, it shows you. The span of a rafter is from the center of the wall to the center of the ridge board. It's the horizontal projection, not the length of the rafter. As the pitch of the roof changes, the rafter length changes. It doesn't matter. As the slope gets bigger, the horizontal component gets smaller, the weight is about the same. Okay? So you want the horizontal component, and of course a floor joist is the dimension between supports. So if you had a symmetrical roof, like a family room on the back of the house, and you put a beam down the middle of it in the basement, you'd have the floor joists and the roof and the rafters spanning the same amount. If you want to make sure you understand it, there's a picture on page 225. Just look at the picture. Makes sense. And we're going to size them. It's pretty simple. If you look at them, let's do 510 first, and we'll do those problems. Table 510 is for floor joists. If you look at the left-hand column, it's the frequency at which the members occur. In our world, I've never built a house with 19.2, but they show spacing of 12-inch center to center, 16-inch center to center, and 24. The most common one by far is 16-inch. If you look at those, all of them are divisible into 96 evenly. 96 is sacred because our panel products, plywood, OSB board, comes in 4x8 sheets. 8 foot is 96 inches. They show floor joists of 2x6s, 2x8s, 2x10s, and 2x12s. If you look at the table, it's busted into 2 cells. First cell, it's got a line underneath it. Second cell. Difference between the two is the dead load. First one is 40 and 10. The second one is 40 and 20. Why 40? That's code. We build houses for a live load of 40 pounds a square foot. Okay, what's the difference between the 10 and 20? What if you put carpet on the floor? Now, what if you put marble or granite on the floor? Granite and marble weigh a heck of a lot more than carpet, so you got to make consideration for that. So you'll figure out what the loading is, then you figure out what your spacing is, and if you know the size of the member or the span, you can just take your finger, run it across, crisscross the two, and you'll end up with either the span or the member size. So let's look at the problem. I'm on the bottom of page 225. The tables were developed, if you read underneath them, for Doug Larch number 2. It says the live load and dead load. It says they're also designed for L over 360. That's what I told you was code. So for A and C. 5.9, A and C. Okay, it says 5.9, A and C. Number 2, live load of 40, dead load of 10, live load of 40, dead load of 10. I'm going to flip the page. For A, I'm going 16-inch spaces at a 14-foot span. 16-inch center to center, 14-foot span. For C, I'm going 16-inch center to center, 16-foot span. Okay, go back to the table. It's going to take us about a second to do this. Okay, get yourself on Joyce. Find the right cell. This says it's the first one, 40 and 10. Put your finger on 16-inch centers. Wander to the right and stop when you get a number that is just a little bit bigger than 14 foot. Oh, it looks like 2 by 10 goes 15.5. That's the answer for part A. Okay, the next one's 16 foot. Go right back where you came from. 15.5 isn't 16 feet, but if you move to the next one, it's 17.10. So this would be a 2 by 12, 17.10. That's it. Okay? That takes care of floor joists. Now we're going to switch gears and we're going to move to the next table, which is rafters. So that's that. So rafter table is 511. So table 511. Let's take a look at it. Same process. I'm going to move over to the problem statements on the next page. It says, using Doug Fir Larch number 2, pick a rafter size. It says live load is 20, dead load is 20. Live load is 20, dead load is 20. Okay, and it says we're doing E and G. E and G. It says 16 inches, 12-foot span. Uh, 16 and 18. And same type of system, look at it. All the words up there except the 20 and 20 tell you